Welcome. In this particular demo, we're going to have a look at how we can manipulate the drawing of bitmaps to a particular canvas object. And in doing this, we'll want to sometimes draw the bitmap, either bigger or smaller, or to rotate it about a particular point, or to fade it in or fade it out. And we'll use these different aspects of how we can draw it by way of providing a lot of the special effects within our games. So I'll show you a demo first of all in terms of the type of activity that we'll want to create. It's in bitmap test. And within here there's a few things to point out. Our reference image is the one showing up on the top left hand corner. And you can see next to it we're drawing that reference image twice, but with an alpha blend value, so we get to see the background underneath it. The ones we have then over a little bit further is actually taking the center segment of the image and drawing that out. And this one here, if you look carefully at the color balance from blue going across the spectrum, in this image it's inverted. We have blue over the other side and it goes across that way. So here we have swapped the image along the x-axis. These two examples down here, it shows us how we can take the full image and draw it out either at a smaller size, at 50% size, or increased at a larger size, as 200% size. And the groups of images over these two here, we have them rotated about a point. So here the top left hand corner is our reference point, and we've got three examples rotated at different angles clockwise around that. Over here, the center of the image is our rotational point, and we have three images rotated again clockwise. Example down here is one of skewing the image, where we are warping it along the x and y axis to give it moving away from right angles to a particular defined angle. And the moving demo you see down at the bottom is where we are combining several different operations together, that we are drawing the rectangle scaled differently at different positions and rotating differently. So we'll have a look at how we combine several of these different effects together. Now the particular piece of code we want to have a look at will be the bitmap test fragment. It is one that contains all aspects of this particular operation. Now it is a simple fragment. We'll have a look here by way of how it works. Within this here, we will be using a number of, for example, matrix transforms to actually do the manipulation. I'm going to assume, I'm not going to, as part of this demo, talk about how those matrix transforms work. I'm going to assume you will have listened to the associated lecture on this, which will talk about how we can encode a particular transform within a matrix, how we can combine them, and the order in which we need to combine them to be able to do it safely. So here we're just simply concerned about how this piece of code works. So a lot of it's fairly standard. We've got our onCreate view. We're returning a new render view, which is our class we're going to have down here for this activity. So this will be a view that will occupy all of the fragment, and the content of that view is what we actually saw in the demo. So we will be drawing out the same rectangle at different locations in different ways, and that will constitute the view for it. In terms of having a look at this here, we've got our bitmap that we're drawing out. We've got a paint instance that we're going to use as well to help us control how we draw that out. And we can use paint for controlling, for example, the font size, the font color. We can also use it for controlling the alpha value with which we're going to blend the source with the destination. We have a couple of rectangles, source rectangle and a destination rectangle. The source rectangle is the one that will be used to reference our bitmap image, so it is relative to the bitmap. And the destination rectangle is the region of the canvas, the screen, to which we are drawing. Thing to remember in all of this here is that for these rectangles, if I hover it over it, the top left hand corner is 0, 0. Positive x goes across to the right, and positive y moves down the image. So when we're specifying our coordinate systems, it will be using that particular frame of reference. We've also got it here defined a matrix class built into Android, and we will be using that for doing quite a few of our manipulations. Here we simply create a new empty one, which we will reuse as we go through. Then we've got a few floating point ones. This is simply for the animation, where we're changing the scale, the rotation, the offset, and if we're making it bigger or smaller. So these 4 things we use to provide the dynamic animation. Now that's the main variables with the bitmap, the paint, the 2 rectangles in the matrix. They're defined up at the top because whenever we go down to our undraw method, we could have defined them in here. So here, for example, I'm setting the paint variable, I'm setting a matrix value, and I'm going to do that repeatedly. It's because I'm doing it repeatedly that I don't want to create, for example, my matrix on the onDraw method, where I would create an object for that draw and then discard that object. Because we're drawing quite frequently, that means that each second I'm creating a whole bunch of objects that would only be discarded. So the reason we declare our matrix and the rectangles and the paint all outside of this is that we can reuse them. These objects are created once. Within our onDraw, we will be setting the values, but we will not be discarding them at the end. We'll be using it next time we go around. So it reduces the overall loading on the garbage collection, because we're not creating unnecessary objects, which we then quite shortly after discard. For the initial class, for the constructor, we give the context that this view is associated with. We're creating a new paint. We try to load in the particular bitmap that we want to display, and that's the setup that's involved. The rest of it is basically the onDraw method, and we will be having a fair amount of code within this. We'll draw it out in different ways. Now, how the onDraw will work, a quick overview. So it's override public void onDraw. So all view objects will have an onDraw method, and we're overriding this to provide control of how we want this particular view to be displayed. When this method is called, we're passed in a canvas object, which is notionally the region of the screen to which we are drawing, and this is what we will use. We will be looking at the contents of this very shortly, but if I zoom down to the end, you see that once we've drawn all the things out, we've got a small try block here. We're simply going to try to go to sleep for 20 milliseconds. This, I mean, arguably this is in the UI thread. We're triggering this one. We shouldn't go to sleep in the UI thread. I put it in here just simply to give a small delay, but that is bad practice. You should generally not put the UI thread to sleep, as it then sort of pauses the whole display of your interface. But the bit at the end is the relevant bit. It invalidates it. Now, if we invalidate a particular view, it effectively is a way of saying that we have changed that view and we need to redraw it. So if you think about what happens here, Android comes along, it calls our onDraw method. We say, okay, here's what you want to have drawn on the screen, and it will duly go ahead and update the canvas with that content, and that content gets to be displayed on the screen. But we immediately invalidate it. So we immediately say, okay, even though I have drawn to the screen, I want to redraw to it again. I need to change it. So in essence, what we have here is an endless loop that the onDraw will draw and then request that it is called again, and that process will keep repeating. And it gives us our sort of simple animation in this particular case. So let's have a look then at the actual onDraw. Got different bits. Draw bitmap at a specific location. So we're going to our canvas, we're calling the draw bitmap method, we're passing in the image, and we're giving it the location relative to the top left that it will be drawn, and we're passing in a paint component that we want to draw. That can be null if we just simply want to draw it as is. This particular method will draw the whole bitmap, so it draws all of the bitmap with the top left corner at on-screen position or on-view position 50/50. Now, if we wanted to do it, to draw it out, but with a defined alpha value other than the default one, we can do this through the paint property. So we've got a paint. We can set the alpha value. It takes in an int from 0 being fully transparent to 255 being fully visible. Having set that, we then can draw out our bitmap again. This time it's the same image, it's offset slightly so the two things overlap, and we're using then this paint with a user-defined alpha value of 125, so it's 50% transparency. And that will draw those two images out, respecting whatever alpha value is in the image, but multiply them by that 50% transparency. Important bit to notice at the end that when we have drawn it out, because we are reusing our paint component, it's important that we remember to go and to reset it in terms of changing the alpha value back to its sort of default, 255. Everything is visible. Down underneath this, we have a couple of other examples here of how we can draw a portion of the source bitmap at a defined location on the screen. Why might we want to do this? If we have, for example, an animation is likely to be a large image, and we will want to draw a frame's worth of content from that source image at a specific location on the screen. That's how we will animate our objects. So here we're making use of the source and the destination rectangles. So we are setting up a source to copy 2525 is the top left, 7575 is the bottom right. So it's the middle square within our source rectangle. And we are drawing it out at that particular on-screen location. Going to our canvas saying draw bitmap, same image as before. Now in this case we're specifying a source and destination rectangle. I'm saying go to paint. So it will take the source from the image and draw it out to the destination rectangle on the screen. The example underneath shows us how we can flip along the x-axis. Why might we want to do this? If we have an animation, quite often the animations are drawn with the character or the figure pointed to the right. If our character was running to the left, then as opposed to having an entirely separate animation of them running to the left in terms of graphics, we simply take our right-facing one and flip it around so it becomes left-facing. So you can see here the destination is notionally the same. Okay, we're offsetting it slightly, but it's the same size definition or destination. We're drawing out in exactly the same way. The only thing that changes is the source. So the top left location is 7525. And the bottom right is 2575. And if you think about that set out, the x direction then is flipped around. We have an x over here and it's moving that way towards the right hand side of it. So it's flipped on the x-axis, and it will draw it out then as such. So these are all methods here we've used our canvas to draw it out, drawing the bitmap, giving rectangles, making use of the paint. We now get on to drawing using a matrix. Incredibly powerful to draw using a matrix, and I suppose by way of contrast here, in the source and the destination, I could have specified the destination rectangle to make it bigger than or smaller than the source rectangle, and it would automatically scale to that bigger or smaller size. So we can use this form here not only to flip it around, but also to control how big or the degree of scaling that we apply. We can use matrices to do exactly the same. So what we're doing in here is we are resetting the matrix. We reset it because we are reusing it. At this point I don't know what changes I made to it in the last frame, but I want to start off with a nice clean identity matrix. It won't change things. So I reset it. It removes any previous transformations I had within the matrix. I can then call the setScale method, which says that, okay, anything drawn through that matrix or transformed by that matrix, I want it to have a scale of 0.5 along the x and 0.5 along the y. In other words, it shrinks by 50%. And the nice thing about matrices is that I can combine several different transformations into one matrix. So one matrix can package up a number of different transformations. So I've set up a scale, and I'm also adding in a translation. So I want to, whatever I'm drawing, to take it from 0, 0, and to move it across to 50, 50 across and 200 down. So it translates all of the points by that 50, 200. And I use that to control the region of the screen that I want to copy the bitmap from. So when I go to Canvas Draw Bitmap, I'm drawing the image, but every single pixel, every single value within that image will be passed through and transformed by that matrix. And that's the particular paint one I'm doing out. So for example, the value 0, 0 would be scaled by 0.5, 0.5, so it's still 0, 0. And it would be translated then by 50, 200. The point, for example, 2, 2, so this is 2, 2 within my image, it would be scaled by 0.5, so 22 becomes into the 0.11. I've shrunk it by 50%. And I then offset it by 50 to 100, so it becomes the 0.51, 201. So it's quite a elegant, quite a simple way of doing it. It's also quite a powerful way. If I want to use exactly the same approach in this time to scale it, here we're setting a scaling value of 2 along the x, 2 along the y, so it's scaling it by 200% as opposed to shrinking it by 50%. Exact same setup then as before, we're just giving it a different translated address. So here in this case, the 0.22, if I scale it, it becomes the 0.44, and I would then draw it at 154, 204. And if you were to go through every single pixel defined within our image, and to do that, we would scale that image over that wider area. Next example we have here is rotation, and if we want to rotate images, we need to use a matrix to do that. Important thing about rotation, well, there's two parameters you have to concern yourself with. One is the amount by which you want to rotate. So in this case, I'm rotating by 15, 30, and 45 degrees. In the same way, distance has as a unit of distance, rotation also has a unit of rotation. We're using degrees here. It's probably the most convenient way for us to think in it, although I have to say in most in frameworks, most sort of maths aspects, rotation is normally measured in terms of radians. So it sort of swings and roundabouts, but Android uses degrees, which is just as well, I think. So you have the extent of the rotation, how many degrees. Importantly, you also have to have the point about which the rotation occurs. So this is the point that is fixed, and all of the other points are rotated relative to that center point. Now, if you don't specify anything, there is a default point of rotation, and it is the 0.00. Sensible. For images, the 0.00 corresponds to the top left-hand corner. So by default, you will translate around that top left-hand corner. So if I showed you it here, running the bitmap test, this is the default rotation over here. So we are setting rotation 15 degrees. We are then giving a sort of an offset where we're drawing it from, and we're drawing out the bitmap using that rotational matrix and using that pane. So every single thing that we draw for that bitmap will be rotated 15 degrees around its top left-hand corner, and then translated out to 475, 200 down. We do it 3 times, 15 degrees, 30 degrees, 45 degrees. Importantly, we are resetting the matrix. If we forgot to reset the matrix, if you think what would happen then is that we would reset it here, rotate it 15 degrees, translate it. If we then did another set rotate, for example 30 degrees, it would be added on to that 15 degrees rotation, and indeed added onto that translation as well. So the point would be somewhere completely different on the screen. So I have to remember to reset it anytime we want to start afresh. The other example down here is where we are rotating about the center of the object, and normally within games that's what we want to do. We want to rotate about the center of the object as opposed to its top left hand corner. Thankfully it's fairly straightforward. We're using a slightly different flavor of the set rotate method, where we specify an angle. It's still 15, 30 and 45 degrees, but we specify a point of rotation. Now it says 50-50 here. 50-50 is the center of this in as far as this is an image of size 100-100. If you had an actual bitmap, it would be better to put in here sort of the width of the bitmap divided by 2, the height of the bitmap divided by 2. But nonetheless, we're rotating around 50-50 for each of these 15, 30 and 45 degrees, and we get it as it appears on the screen. The final one we have is skewing the matrix. Generally, we don't use it that often within games. You may have sort of a wavy effect where you could do that. We have a nice set skew method where we can control the amount of skew in the x and the y axes. We do that, we give it a draw location, and we pass it through. And if you want, you can sit and tweak these values and see the effect that it makes. Now, the real power of matrices is to be able to combine them to get this type of setup, that we could have an object within our game that maybe we want to, if you go to bigger scale or a smaller scale, we want to have it rotated so it's pointing in the direction in which it's traveling. We want to give it a certain location within our world. All of these things we can quite easily package up within a matrix. The lecture talks about the sequence, the is-rot sequence, to make sure we do this safely. We start off with identity, which is the same as resetting the matrix. Then we scale it if we need to scale it. We rotate it about its center if we need to do that. We rotate it around some other arbitrary point if we want to do that. And finally, we translate it as to where it exists within the world. Now, the example we have here is one where we've got a bunch of variables for the scale, the offset, and the rotation. These are the things that are varying within the demo. And simply, the scale is we're getting bigger or smaller depending on the scale direction up until the range 0.75 up to 1, or 0.125 down to -1. So we're sorry, other way around. We're scaling between 0.75 up to 1.25. Scale direction is used to control that if we're getting bigger or smaller. Offset direction, again, if we're depending which way we're moving, to the left or to the right, we'll do that. And rotation, we're always rotating around in a clockwise positive direction. So you can see down here where we actually set up our matrix. We reset it, gets back to the starting value. We set the scale to be whatever we're using at the minute. We set the rotation to be whatever our current rotation is about the center of the object. Now we don't have any orbit. If we did have an orbit, then it would be rotating around that orbit point. And finally, we translate it. Here we are translating somewhere along the x-axis with a defined offset for that. And then finally drawing it out. So it's reasonably simple. It's incredibly powerful because there's an awful lot of special effects that you can tease out by way of producing this. And hopefully for your games you will be planning how you can make use of these draw facilities to put in place whatever sort of graphical features you need to have.